Hi, I'm Randall Heyman, a mathematics academic. Welcome to my Corona Help playlists, where I do quick turnaround videos for educators and students. If you'd like me to make a video or videos for you, then just drop me a comment under any of my videos, or if you want, you could send me an email. Actually, let me line all this up. I'm working through some concepts in analysis for Lydia from the UK, and I wanted to talk about connected sets, or she wanted me to talk about connected sets. So I suppose to start with, we might talk about path connected first, which you may have seen in previous years. So the idea of path connected is fairly simple. Here's a set S, and we'd say that S is path connected if you could pick any two random points, say X and Y, that you can construct a path between them, that it remains within S the whole time. So there's a path, and I think you could see there for any X and Y, we could that are in S, we could do that. On the other hand, let's look at this set. So this is T1, T2, and I'll call T the union of T1, the union of T1 and T2. Well, now this is not path connected because I can construct, let's put an X here and a Y here, and there's no way you can construct a path between them. We can get up to here and then we're going to have problems. And it doesn't matter which way we head, we're going to have problems getting out of T1. So this is not path connected. Now, path connected works well. For example, you can show that if what can you show? If A is a set that is path connected, then if you have a continuous mapping F across to, so here's A, and this is F of A. If A is path connected, F is continuous, then F of A is path connected as well. So it's got some uses, but one of the problems is it's not, we need something a bit better as we progress. One of the trends we may have seen if you've watched the videos I've done is that there's this movement, we sort of have these metric spaces, which I did a video on, or more than one actually. Spaces, you know, X, D is distance or metric here. And one of the things we're sort of, mathematicians work towards is something called rather a metric space, a topological space, which adopts the same sort of ideas here, but it's more general, and it's more general because we don't need this D, we don't need a metric for topological space. And the key concept with topological sets is open sets, which we've talked about. And I think in one of the previous videos, we talked about how do we define continuity if we don't have a metric. Well, we can use open sets, which is, I laboured that in a couple of videos. So we need a better definition of connected sets, and we need something that sort of uses open sets. So here's our definition. Well, we'll start with disconnected or not connected. A set S, which is, say, a subset of a bigger set X, is disconnected, or we might say not connected. If there exists disjoint open sets U and V such that the intersection, let's put this one first. A must be a subset of U, UV. So this is the set U here, and this is into the union. So actually maybe what I'll do is I'll actually write up here, i.e. the union of U and V. And the second condition is that when we take A intersection U, that must be, well, it cannot equal the empty set. I think the empty set is generally like that. And the same with V. Okay. And so otherwise, if that's not the situation, then otherwise S is connected. So that's good. Let's do an example. I'll leave this up there. That's probably as good as we get. So let's think about S, which will be the set. So I'm making this disjoint. The set 0, 1, union 2, 4. So what we think about here is here's 0 to 1 on the number line. Whoops, 1. Actually, a better way to do it would be like this. Sorry, let's do it this way. Let's just lightly draw that, the number line, the real number line, and here we'll put 0, 1, 2, 4. So that's a representation of it, and you can see that that's, well, it's certainly not path connected. You can't get from one of those sets to the other, but we'll show that it's also not connected, or it's disconnected. So how will we do that? Well, we've got to come up with disjoint open sets. So actually, let's just write here, show that S, this is actually a subset of the reals, is disconnected. So I mean, the basic idea here is I'm going to set up a little open set here and an open set here. They'll be disjoint, but they'll cover A. So let U equal, now we need an open set, so let's let it equal -1. Let's let it leave 5 on 4. And let's let V equal an open set, needs to be open. So 1 3/4, what's that? 7 quarters, 5. Okay. So 1, U, V are open sets. U intersection V equals the empty set. So U, V are disjoint. You could just state that it's disjoint. You wouldn't necessarily have to write that first bit. Now we want to get that first line in. Is that all? Is disjoints U open sets? So we've said they're open, they're disjoint. Okay, so also A, well, in this case, we're using S, aren't we? So S is a subset of U union V. Is everybody happy about that? S, why S equals 0, 1, union 2, 4, and U, V equals -1, 5/4, union 7/4, 5ths. So you could easily show, if you had to, that S is a subset of the union of U and V, and also And finally, A intersection U. Well, we might actually give an example why it's non-empty. So 0 is an element of A, 0 is an element of U. So A intersection U is not the empty set. And we can do the same thing for V. 3 is an element of, you could do it this way if you wanted, A intersection U, V. Let's make that V. So A intersection V is not equal to the empty set. So therefore, S is not connected. Little bit harder problem. You might like to pause this. What about the set Q, the rationals, which are a subset of the reals? Is Q connected? Have a think about that. And I think the answer is no. Why? I'll let you work through this yourself. You could set is -8 root 2, V equals root 2 infinity. Well, we certainly have their open sets. They're certainly disjoint. The rationals do sit inside the union of U and V. And what else do we need? The intersection of Q and U is non-empty, and the intersection of Q and V is non-empty. So that'll work, but you might like to write that out more fully. If you've got any questions on any of this, then please comment me below any of my videos or drop me an email.